Alright, so 6.4, it's rational exponents. Now, we're going to do two things. You're going to write it in radical form, and you're going to write it in exponential form. The good thing is, we've already done both. We're just going to go back and define it just a little bit more clearly as we're going through this one. Okay, so when we're doing this one, in radical form, we had n was the index. Of course, p was the power we were doing. And now we've actually done this, but we didn't actually call it this when we were doing this. When we had to simplify some of these, this would be radical form. If I can spell radical. And they're going to ask you to rewrite it from radical form to exponential form. And vice versa. Sometimes we're going to go from exponential back to radical. Okay, so if we were doing this on the last test, what did we do to simplify these two numbers? Just divided it, right? We kind of factored out, but the main thing was we were going to divide it, so that was x to the p over n. And that's what they're going to call exponential form. So we were doing that already, we just didn't call it exponential form, but that's what exponential form is. It's just taking this index and this power, dividing those two things, and that's going to be what they're going to do. And what they're going to have you do in some of the problems is they're going to have you take some of these problems and you're going to rewrite it from radical form to exponential, and then we're going to rewrite it from exponential back to radical form, and then we're going to show you some properties where you can do some different things with the different numbers when they pop up here. Okay, so for these, now we're not going to do any solving or simplifying on these. This one you're simply going to just rewrite it, and that's all you're going to do. So we're going to rewrite this in let's go in exponential form. And then in a minute we'll go the opposite. We're going to take something in exponent form and rewrite it in radical form. Alright, so square root of 36. Now again, I know we could simplify this one, but right now we're not worried about simplifying it. We're simply just going to rewrite it. Alright, if it's square root of 36, index is understood to be 2, so this would be 36 to the 2 bigger denominator. This is 36 basically to the first power. So it would be 36 to the 1/2 power. And they just try to get you to see these that, okay, if you have the 1/2 power, that's the same thing as doing the square root of a number. If this was the 4th root of 16, that's going to be 16. Your 4 is going to be your denominator. Again, if there's not a power there, we'll just put it as 1. And if we had the 7th root of x to the 4th, again, they're just asking us to rewrite it, not simplify or anything else with it. That would be x to the 4 divided by 7. Okay, and all they're trying to get you to think about is, alright, if we're doing some of these numbers, just rewriting it, and sometimes we're going to show you some properties in a minute where if you have numbers written like this, we can actually simplify these pretty quick by using a couple of properties. And some of the properties we already know, we just haven't actually defined them. We've been working with them, but we'll actually kind of look at some definitions of them. Okay, for the next couple of problems, what we're going to do is we're going to go the opposite. We're going to take these, and let's rewrite these in radical form. Sure. Right. Okay, so this one we're going to start with an exponential form, so we're going to start with x to the 3/11, and they're going to ask us to rewrite it in radical form. And again, 11 is your index, so that's going to be out here. You've got x to the 3rd, So it could go there. Now, in this one, actually, there's two different answers that you can kind of do with this one. If they ask you just to rewrite it in radical form, you can do this answer. If it ever asks you to simplify, which we'll do some of those later, you can actually put the x to the third. Instead of doing the third on the inside, you can actually do the third on the outside. So if they ask you just to rewrite it, this would be a good answer. In a minute, when they ask you to simplify it, you actually want to take that third power and put it on the outside, and we'll show you why that is when we do a couple of them here in a little bit when we actually start simplifying. So for now, we're going to go ahead and do both. This will be the best answer to rewrite it. This would be a better answer if we were going to simplify it. Okay, so let's do another here. Let's do w to the 8/5 power. Okay, so they ask you just to rewrite it. Again, the 5 goes on the outside, the 8 stays on the inside. And again, if we simplify this later, you can actually do it two different ways. You can do the 5th root of w, and then do that whole thing to the 8th power. Again, if it's just a rewrite, this is good. When we start simplifying in a minute, this is actually going to be a better answer that we're going to look for. Okay, now they're going to get a little sneaky on some of these. So let's say you've got x to the 0.2 power. It's not a fraction, right? But what is 0.2 as a fraction? What place value is the 2 in? It's in the which decimal place? Tenths, right? Because one decimal place is tenths, the second one will be hundreds. So if you think about this one, this would be x to the 2/10 power. But you can simplify 2/10, right? That'll be x to the 1/5. And now that you've got it in a simplified fraction, now we can take this thing and rewrite it. So that would be the 5th root of x to the 1st power, but if it's the 1st power, you really don't have to put the 1, so just 5th root of x would be okay. Okay, and one more. Let's go with y to the 3.5 power. Okay, same kind of thing. It's a mixed number, and we really want just a plain fraction. Now, and it's okay if it's improper. Up here on the early two examples, this was 3/11. This one was improper. It was 8/5. So either way we go on this one, it just needs to be a fraction. So let's make it, obviously it's going to be improper. And going back to 6th or 7th grade math here, how do we change 3.5 so it's an improper fraction? There you go. So you're going to multiply these two numbers, and then you add the 1 on top. So 2 times 3 is 6. 6 plus 1 is 7 over 2. And now that you got it in fraction form, then you can rewrite it. So it would be the 2nd root of y to the 7th. Again, if it's 2nd root, you don't have to put the 2, because that's always understood. If that's 2, you don't have to have it. So we can say it's square root of y to the 7th. Or again, you could have the square root of y and then the whole thing to the 7th power. So either one of those two answers there would be okay. Okay, so there's what they're going to have you just, in those cases, you're not going to do anything with those problems, just simply rewrite it. And that's all you're going to do. Here's one where they're going to ask you now to simplify. And if you have one like this, we're not used to seeing the fraction exponents, because that throws us off. So for these, if they ask you to simplify, if you're given exponential form, And we're not really, so far, we're not really good at seeing this thing yet. So what we're going to do is we've got this exponential form. We're used to seeing radical form. So when we're given the exponential form, we're going to rewrite it in radical form. And once we do that, it should be a number that should just kind of jump out at you when we see this. So we've got 64 to the 1/2 power. This is an exponential, which we're not really used to seeing. So let's rewrite it in radical form. So it's going to be the second root of 64 to the first power, which again, we don't really need the 2. 64 to the first power is just 64. So what's the square root of 64? It's just 8. And here's the good news with everything we're doing in this section. You don't have to worry about any absolute values. On these, we don't have to worry about the negative numbers. If it's square root of 64, we're not going to do the plus or minus 8. Just give me the regular whole number without any negatives, and that's good to go. The only time you have to worry about a negative answer is if we're doing, and we'll show you one here in a second, where if they give you a negative inside the number, then the answer is going to be negative depending on what we're doing with it. So this one, you don't have to worry about the absolute values or the plus or minus. If it's square root of 64, just tell me it's 8. That's it. If it's square root of 25, it's just 5. So we don't have to worry about everything. They just assume that everything's going to be positive, you know, if we have to worry about any of those. Okay, so let's go 11 to the 1/2 power and then times 11 to the 1/2 power. Okay, so for this one, 11 to the 1/2 power, that's going to be just the square root of 11. Same thing for the second one, that's another square root of 11. But if you've got square root of 11 times square root of 11, that is 121. And if you take square root of 121, well, if it was 11 times 11, then that means it's going to be just 11. So if it's 11 squared to get 121, when you square root it, the square and square root cancel.
You also can do it if you're like, if you multiply the two square roots, you just cancel them out, and it's just 11. Yep.
So it's basically, if it's 11 times 11, it's 11 squared. Yeah, and then your squared and your square root cancel, and then you just got 11 there. Yeah. All right, here's one that will hopefully jump out at you a little bit different. So we've got 3 to 1/2 and then 12 to the 1/2. So if it's 3 to 1/2, that's the same thing as square root of 3. 12 to 1/2, that's the same thing as the square root of 12. All right, we can multiply those numbers together. 3 times 12 is 36. But what's the square root of 36? There you go. It's plain old 6. Okay. So, and that's what they want you to do. If they give you just a number that you have here, you can basically just think about that one and rewriting it in radical form. And then once you've done that, then you should have something that you can break down, whether it's just a regular perfect square root, or once you multiply together, then you get a perfect square root that you have, and then you can kind of go from there. Okay, so the first half of the chapter, the first half of this section, it's just, here's some numbers. Let's just practice going from radical to exponential, exponential back to radical, and then we'll do a little bit of simplifying on top of that too. But mostly it's just being able to go be comfortable to go back and forth from exponent to radical or radical to exponent, just so we can work with it. Okay, and then halfway through, once you've gone through this in the first half of it, the second half we're going to do exponent properties. And there's really, I guess, two kind of new ones. The other two we've done before, and so these should be okay, but there's two new ones we're really going to look at. Okay, and this is one. If you think about this first one that's here, where we've got a to the m times a to the n. We've already kind of done this one. And let me just kind of flash back to a problem that we've done real quick. That if you think back to the last test we had, if we had x squared times x to the fifth, what do we do with those exponents? We just add them together, right? Because if you've got 2x's here, 5x's here, we just put it all together and made it x to the 7th. So we didn't really define what it was, but that's one of the basic exponent properties. That as long as these two bases are the same, you can just add up the exponents. Because we were doing that when we were multiplying the inside the radicals together and combining it together, and then we would go back and break it down. So that was one that we had that we'd already kind of talked about. Okay, we also talked about this one when we were working through some of the properties. If we had a to the m divided by a to the n. And if you think back to the last test that we were working with, that was where we had like x to the 7th over x to the 4th. What would we do with those exponents? It's like the old school canceling, right? If you had 7 x's up here, had 4 on the bottom, you could cancel those out and then see how many you had left over. So this one, if they're dividing those numbers out, then basically the shortcut is you just subtract those two exponents, m minus n. Okay, so those two, we've kind of used those two, so hopefully that's not anything new that we've already been talking about that. Here's the part where we kind of sneak in a couple of new things. Let's say that inside the parentheses you've got something already raised to a power. We're doing a to the m power in this case. And then you've got another power right on the outside of it. So this would be like if you had x squared to the 3rd power, if you were thinking about with numbers. Well, if it's x squared to the 3rd power, that means you need 3x squareds. And if you've got 3x squareds, if you add all these up, we get 6. So the shortcut is we can just multiply these two numbers together. So if we've got to simplify this one, we're just going to do a, we're just going to do m times n to get the exponent. Okay, now one that's kind of a little bit of a spin-off here. So if you had a times b to the n power, that you almost have to think about this one as having, that each one of these has like a first power on it. And it's almost like when you have more than one variable in there, this n is going to be multiplied by all the powers. So you're going to have a to the n power, and you're also going to have b to the n power. So it's almost like a distributor property. So if we had one like this, just to kind of give you almost the numbers here. Let's say you had x squared and y to the 3rd to the 4th power. If you had to simplify this one, you're going to do x, you're going to do 4 times 2, make it x to the 8th. For the y, you're going to do 4 times 3 and make it y to the 12th. And usually that helps more than anything else to kind of see one where you've got real numbers with it instead of just all variables. So if you have more than one letter, you've got to take this 4, whatever the outside power is, and multiply by every single variable that you have on the inside. If you've got more than one variable, you've got to do it multiple times. Okay, and then the last thing, if we can get it right here, hopefully. If you have a raised to some negative power. Now, I think we talked about this way back when, but it's been a little while since we've talked about it. So here's where we'll actually define it and go through here. If you have a to the negative p power, if you have a negative with the power, that just means it's in the wrong place, if you want to think about it that way. That if you've got a negative power and it's in the numerator, that means you've got to move it to the denominator. And when you move it to the denominator, that will change the sign from being a negative power to a positive power. And on the split side, if you started with 1 over b to some negative power, if it's in the denominator, to take the negative off the power, that means you have to move it up to the numerator, and that will take the power off of it there. So anytime you see a negative exponent, that just means it's in the wrong place. If it's in the numerator, you got to move it to the denominator, and that will make the power positive. If it's in the denominator, that means it needs to be in the numerator. And whenever you move it from numerator to denominator, or vice versa, that takes the negative off of that power that you're going to do. And that's kind of what we did back here with the a to the m minus n, that when we moved this up here, it was a positive, but when we move it up to the numerator, now it makes it a negative. So that's kind of, these two kind of go together because they're almost, if you think about it that way, they're kind of connected there. Okay, so there's your 1, 2, 3, 4, 5 properties. And again, these two are basically the same thing, just kind of spin off a little of those. But what they're going to ask you to do is they're going to give you some examples. We're going to walk through some of these where they're going to tell you, all right, use your exponent properties to simplify this thing so you don't have to rewrite it. And when you see these, sometimes you go, oh, well, that was pretty quick. And then that was, you know, sometimes it's quicker than having to rewrite everything we were doing anyway. Okay, for these, we are going to simplify, but we're going to use the exponent properties. So this one, we're not going to worry about rewriting it, changing it back. This one, we're going to use the properties to get an answer. And hopefully when we do these, you'll see that the answer comes out pretty quick. Okay, and we'll do a couple of these, and then or actually 3 of these, and then we'll do some other different properties where you can just you can simplify it every way you want to. So for the first one on this one, we're going to do 8 to the 1/3 power and then 8 to the 2/3 power. Okay, key thing on this one is the bases are the same. So we've got 8 and 8. So we're going to leave the 8 alone, and then we're just going to do 1/3 plus 2/3. But what is 1/3 plus 2/3? 1 plus 2 is 3, so it's 3/3. So what is 3/3? It's just plain old 1, so that's 8 to the first power, which is just 8. So there's one that we could go back and rewrite it and take the cube root of it, and then take the cube root of the other one and square it and do all this other stuff. Or if these bases are the same, the short way is just add those two numbers together. Happens to be the fractions, but we're just going to add the fractions together. We've got 8 to the first power, which is just plain 8. So there's one. Now, we did that earlier with, to go back to this example back here, we did the same thing back here with the 8 to the 1/2 and 8 to the 1/2, so we had our square roots. But a lot of these numbers, they're not going to be square roots. They're going to be something other than square roots, which makes it a little bit more difficult to think about it. Sometimes they'll give you, this case we had 3rd roots. Sometimes these will be 5th roots or 7th roots. And we don't think about 5th roots and 7th roots all that much. So it's just a way to kind of get around it there. So I'm going to do 5 to the 1/2 power to the 4th power. Okay, and again, we're not going to rewrite it, so we're just going to use the properties. And that's where we're back to the a times mn. We're back to this thing. We've got a number here and then the power outside of it. So we can just multiply those two together. So it's 5 to the 1/2 times 4. So it's half of 4. That's 2. 5 squared is 25. There you go. So if they ask you to use the properties, it should work out pretty easy when you go through the numbers on this one and put it all together. Alright, this problem is going to jump right out at you because we had a problem like this on the test yesterday. At least I think we did. We had the 3rd root of 3, sorry, square root of 3, and then the 4th root of 3. And if we had that test question, could we do that? No. No. Because if the indexes were different, we said all bets were off, these indexes have to be the same. And when the indexes are different, then too bad, so sad, we can't do it. But if we use the exponent properties, which means we're going to have to rewrite these in exponent form, this would be 3 to the 1/2 power. Because again, that's understood 2 here. This one would be 3 to the 1/4 power. Well, now this one looks a lot like example 1. So as long as we have the same bases, now we can add those exponents together. So it's going to be 3 to the 1/2 plus 1/4. Now the only bad news with this one is you don't have common denominators, so you have to rewrite it. But the good news is if it's 1/2 and 1/4, common denominator would be 4. So if you take 1/2, that would be 2/4 plus 1/4. So that would be 3/4. And depending on the answer, we'll do both answers here. If they ask for the answer in exponential form, that would be our exponential answer. If they ask you to take that answer and not have it in the exponential form, if they ask for it in radical form, that's where you're going to take this final answer and go back and rewrite it in radical form. So this 4 is here on the bottom, so that means it's the index, so it goes out here. And then we've got 3 to the 3rd power, so that would go in there. And since you can do 3 to the 3rd power, 27. So that would be your answer in radical form. Okay, so we've got exponential form, you've got radical form. They, depending on which way they ask for the answer, just depends on which way you want to put it. Exponential form, you can leave it here. If they ask for radical form, take that answer and rewrite it in radical form. And then if you can simplify a little bit, then just simplify a little bit. Okay, and for the last handful of examples, here's where they're gonna tell you to simplify, and you just can do anything you want to do. You can do radical form, you can do the properties if you can. It's basically just here you go. Here's an example, and just work it out the best you can. So this one you may or may not use the properties for the rest of these. So let's go with 16 to the negative 2.5 power. Okay, and you can do this one a couple of different ways. Hopefully the first thing that jumps out at you is it's a negative power. So let's change it back so it's a positive power. So since that's in the numerator, we've got to move it to the denominator. And that'll change it from a negative to a positive. So that's the first thing is they're going to tell you make sure you don't have any negative exponents in your answer. Okay, 16 to 2.5. It's in a fraction or decimal form. So if it's here and we can't really do anything with it where it's in an exponential form, that means we're going to have to rewrite it in radical form. Now, 2.5. What that be is if it was a fraction. So 2.5 would be 2.5. Again, now we're back in 6th grade math because now we've got to multiply the denominator times the whole number, add that to the numerator, so that's 1 over 16 to the 5 over 2 power. And that's terrible, so I'm going to pull it over here. Okay, so take the 2.5, which is really 2.5, take that out of being a mixed number back to it's an fraction, whether it's regular or improper, doesn't matter. And then we're going to rewrite that part. So that's the square root of 16 to the 5th power. Okay, now here's where we want you to kind of think about this one. Do you want to do the 16 to the 5th power first, or do you want to do the square root of 16 first? Because which one do you know the answer to? Can you do 16 to the 5th in your head? I can't. I mean, if you can, more power to you. That's great. That's awesome. I'll give you a starburst for that. Square root of 16. I can do square root of 16 in my head, right? Because square root of 16 is 4. So let's do the square root of 16 first. So that's 1 over 4. And then we're going to do 4 to the 5th power. And you may say, well, I can't do 4 to the 5th power. No, but I can do 4 to the 5th power a lot easier than I can do 16 to the 5th power. So if we do 4 to the 5th power, that's 16 times 16 times one more 4. If we check that real quick with the calculator, that'd be 1024. So when you're doing these, you can do these, all kinds of different ways. But the main thing is, if they give you one that's in exponent form and you can't simplify it, you're probably going to have to rewrite it in radical form. And then once you get it here, then you should have something you can kind of simplify. And then on the flip side, if they give you something in radical form and you don't know what to do, then you probably have to rewrite it in exponential form, and then it should work its way out. Now, if somebody's saying, well, I could do 16 to the 5th power on my calculator and then do the square root of it, that's fine, but we just try to get you to think about that, if you don't have a calculator, it's easier to do the square root of 16 than it is to do 16 to the 5th power. So you can do either one of those two, you just have to figure out which one you want to do first. Sure, fire away.
So how do you get 1,044?
Oh, that basically you just do 4 times 4 times 4 times 4 times 4. Or if you've got the calculator, you can do 4 to the 5th power. Some of them you can just punch that in. Now if we're using the TI calculators, that's where you can do the 4, do the rooftop, and then do the 5. And that would get you to that 1024. Alright, we haven't done one with a negative yet, so let's throw a negative number at you. Let's go negative 32 to the 4/5 power. We've got negative 32 to the 4/5 power. There's nothing really you can do. There's nothing to add to it. There's no multiplication. That fraction's in simplest form. So this one, if you've got it in exponential form and you can't solve it, and you don't know what to do, that's where you want to take it and rewrite it in radical form, and then you should have something that should jump out at you. So that's the 5th root of negative 32 to the 4th power. And again, you've got two options on this one. You can do negative 32 to the 4th power, or you can do the 5th root of negative 32. And for me, I would rather do the 5th root of negative 32, because if you check that one real quick, negative 32 is negative 2 to the 5th power. So that way your 5th root and 5th power would cancel each other out and leave you with just a negative 2. And then we can take negative 2 to the 4th power. And that's a little bit easier to do than multiplying 32 to the 4th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And when you do a negative times itself 4 times, that will make it a positive. If that had only been a 3rd root, then that would have been a negative. If you multiply negative 3 times, it makes it negative. But because we did it 4 times, it's going to make it a positive. Okay, let's do 2 more. 2 more and then we're done. Let's do 8x to the 15th to the negative 1/3 power. Okay, now before we do this one, there's one little small thing on this one we're going to do. We've got 8x to the 15th to the negative 1/3 power. X is to the 15th power, but what is the 8th to the power? It's to the first. That's the one that will kind of sneak up on you sometimes, because a lot of times people will see that they're going to multiply the negative 1/3 times the x power, we get that. But because it's 8 times x to the 15th, those are like, you got your coefficient, you've got your variable. that it's still 8 to the first power, that you still have to do 8 to the negative 1/3 power. And that one sometimes will sneak up on people. So it's 8 to the negative 1/3 power, and then x, when you do negative 1/3 times 15, that's going to be negative 5. And both of those have the negative exponents, so let's move them down to the denominator. So that's 1 over 8 to the 1/3 power, and then x to the 5th power. Because once we did the distributive property with the negative 1/3, now we've got a negative answer, so that means we've got to move them out of the numerator, move them down to the denominator. And 8 to the 1/3, again, if you think about that one, if you're not real sure what it is with 8 to the 1/3, just think that is the third root of 8 to the first power. And if you check the third root of 8, that's 2 times 2 times 2. And because it's the third root of 2 times 2 times 2, there's 3 2s, so we can take that 2 out. So your final answer would be 1 over 2, and then x to the 5th. All right, one more, and then we'll save the best for last. Toughest one we've got to do. And after we do this one, we'll wrap it up and be done. Do 9 times x times the 4th root of y. We're going to do this to the 3 over 2 power. Right, and two things on this one. Again, it is 9 to the first power. It's also x to the first power. And this one, because it's in a radical form, let's rewrite it so it's in a power form, exponential form. So that would be y to the 1/4 power. So anything number or variable-wise that doesn't have a power, go back and put a 1 on it, just because you're going to kind of hold that there like a placeholder almost. And once we've got everything written so they all have powers on them in exponent form, then you can take the 3/2 and multiply it by all the powers. So that's 9 to the 3/2. That's x to the 3/2. And for the y, that's going to be 3 over 8. Okay. And then we're going to simplify each little piece as much as we can. We're going to simplify the 9, we're going to simplify the x, and we're going to simplify the y. And each one of those things individually, when we put it all back together, is going to be the answer. All right, for this one, again, 9 over 3 over 2. We don't really do a whole lot with exponential form because there's nothing to add or subtract the 9 with, so this one we're just going to have to rewrite it. So that's going to be the second root of 9 to the 3rd power. And it's the square root of 9, which is 3. So that's 3 to the 3rd power. And if you do 3 to the 3rd power, that is 27. Okay, so 9 and 3 over 2, if there's nothing to do here, just rewrite it and then break it down. For the x, this is where we're actually going to divide 2 into 3. 2 will go into 3 one time with 1 left over. So for the x's, we're going to have 1x that goes on the outside. We're going to have 1x that's left on the inside. And just make sure, because this index was 2 here, that that's going to be square root, so we don't really have to put the 2. And then for the y's, we're going to take 8 and divide it into 3. Will 8 go into 3? It won't. So that leaves us 0 here, so that's 3 there. So when we break this one down, we have no y's on the outside. We're going to have 3 y's on the inside. And because we were dividing it by 8, that means that's going to be the 8th root of y that we're going to put there. And that would be the final answer that we're looking for. Okay, now somebody may be asking, well, on the last test when we did this, everything inside and outside, we put it all underneath one radical sign. We did, because every index was the same. Back here, this would have been x. If that would have been y squared, we could have done that. But because that's the 8th root of y, it's its own separate little problem, because this one was the square root of x, if we think about it that way. So if the roots are different, if the indexes are different, then they're almost like 2 separate problems.